Greetings and salutation to my fellow viewers. In this given chance, we from Group 2 of Communication Principles will be going to present our presentation video on data communication, mainly on amplitude modulation, angle modulation, and radio digital modulation. So without further ado, let's begin.
Before diving deeper into the presentation, I would like to introduce the honorary members of our group. Stephanie as the group leader, me, Daniel, and Wilson. We are all responsible in presenting and finishing this presentation video. Let's take a look at the table of content to grasp the big picture of this presentation. First, we begin with modulation. So what is modulation? Modulation is a process of converting data into radio wave by adding information to the carrier signal. The signal transmission is transformed to suit the transmission medium, which purpose is to shift the frequency to a higher frequency. There are two types of modulation, which include continuous wave modulation and pulse modulation. For amplitude modulations, amplitude modulation is where the amplitude of the carrier signal will be modified based on the modulating signal. Take a look at the diagram here. We have message signal, also known as modulating signal. It can be audio signal or video signal. We also have carrier signal, in which the frequency of carrier signal should be greater than the frequency of modulating signal. The message signal and carrier signal will pass through a modulator, and the output will be a modulated signal. Let's take a look at the general formula of amplitude modulation for ideal cases. It comprises of two parts, mainly the envelope equation and carrier signal. Now, for the frequency spectrum of amplitude modulation, we have the component of lower sidebands and upper sidebands. Note that the bandwidth is the 2 times distance of modulation frequency, or twice distance of modulation frequency. We know that carrier frequency is greater than modulating frequency. So a signal with a higher carrier frequency will transmit more information in a given bandwidth. For instance, higher carrier frequency allows more bandwidth for modulating signal. Plus, more information can be transmitted simultaneously. For example, higher data rates for audio or visual signals. Modulation index is a measure of how much the carrier amplitude varies due to the modulating signal. The equation is given by M equal to EM over EC. EM stands for peak amplitude of the modulating signal, and EC stands for peak amplitude of the carrier signal. Let's take a look at the graph over left here. When M is equal to 1, it is a critical modulation, where the carrier signal fully represents the modulating signal, and the carrier's amplitude reaches 0 at its lowest point. But when M is lower than 1, it is an undermodulation, where the carrier signal is not fully utilized, and the results in weaker transmitted signal. Furthermore, when M is greater than 1, overmodulation occurs, where it causes overlapping and phase reversals in the waveform, and leads to distortion, making the original signal difficult to recover. Demodulation is the process of extracting the original message signal from the received modulated signal. It is performed at the receiver end to recover the transmitted information. The application of demodulation could be seen in AM radio, where the audio signal was extracted, and in telecommunication, where recovering voice and data in communication system.
Hi guys, I'm Wilson. So next part is about the angle modulation. So angle modulation uses modulating signal to change the phase and also the frequency of the carrier signal. So it consists of two types of modulation. First type is phase modulation PM, and the second type is angle modulation AM. So below is the general formula of the phase modulation and frequency modulation. For left hand side, the KP stands for phase deviation constant in radians per watt unit, and the right hand side, the KF stands for frequency deviation constant in radians per seconds per watt. So the constant is the difference between these two formulas, and also the frequency modulation formula have the integration of the modulating signal. So next I'll talk about the relationship between frequency modulation and phase modulation. The figure below shows that the FM and PM are actually interrelated, which means we can actually generate the FM signal by using PM modulator and generate PM signal by using FM modulator. So next I'll talk about the demodulation process. Both frequency modulated signal and phase modulated signal can be demodulated and get back the modulating signal. The PM demodulator can be used to get back modulating signal from the frequency modulated signal, while the FM demodulator can be used to get back modulating signal from the phase modulated signal. So the figure below shows that the demodulation process of the PM and also FM signal. There are two types of FM modulated signals. So the first type is narrow band frequency modulated signal. The modulation index beta is smaller than 0.2. And the second type is wideband frequency modulated signal, and the modulation index beta of wideband frequency modulated signal is bigger than 0.2. Okay, next is the MBFM generation. We can generate the MBFM signal by using Armstrong, which is the indirect method, through using a phase modulator circuit. So for the WBFM signal generation, a frequency multiplier is used to increase the carrier frequency and the frequency deviation of the MBFM signal. The frequency deviation increase leads to an increase in the modulation index beta. A band pass filter is applied to ensure that the output signal meets wideband frequency modulated signal specifications by retaining the desired bandwidth and eliminating unwanted frequency.
The next topic is radio-digital modulation. This technique is similar to the analog modulation in which the modulating signal will vary the amplitude, frequency, or phase of the carrier signal. The only difference is the modulating signal used in this modulation is digital signal. There are three types of digital modulation techniques. The first is amplitude shift keying, also known as the on-off keying. It encodes digital data by varying the amplitude of the carrier. We can see in the red box when the binary input is equals to 1. The output signal is generated same as the carrier signal. And we can see in the yellow box, when the binary input is equals to 0, there is no output signal generated. And this is what known as the amplitude shift key. The second digital modulation technique is frequency shift key. The frequency of carrier signal will vary with amplitude of message signal. The two binary states where logic 0 represent low frequency and logic 1 represent high frequency in binary frequency shift key mechanism are each represented by an analog waveform. In the red box, when message signal equals to 1, the output signal will refer to high frequency as its output. And when message signal is equals to 0, the output signal will refer to the low frequency as its output. And this is how FSK works. The third digital modulation technique is phase shift key. The phase of the carrier signal is varied according to the digital data to be transmitted. In this video, we will discuss for two types of PSK. One of it is binary PSK. For binary PSK, the phase will change from 0 and 180 degrees, while for the quadrature PSK, the phase will change in 4 phases. And now let us see for the binary PSK. In the red box, when the logic state changes, the phase of the carrier will shift by 180 degrees. In the yellow box, when the logic state does not change, the phase of the carrier will remain the same. Quadrature phase shift key. 2 bits will modulate at once. Select one of 4 possible carrier phase shift. QPSK will carry twice as much information as ordinary PSK using the same bandwidth. We can see when the bit is 00, the phase shift is 0 degree. The graph remains the same. When the bit is 10, the phase shift 180 degrees. When it is 01, signal initiate from 90 degree phase shift. When it is 11, the signal initiate from 270 degree phase shift. The next topic is latest advancement in digital modulation for 6G. The key advance in digital modulation for 6G. Higher order modulation scheme. By modulating both phase and amplitude of radio wave, this technology enhances spectral efficiency and enables more data to be transmitted. Second, machine learning enhanced modulation. 6G system can optimize modulation parameters in real time with the use of machine learning algorithms. The terahertz communication modulations. The terahertz modulator have been developed to achieve the high modulation depth, rapid modulation speed, and broad modulation bandwidth. The benefits of 6G. It has better security to protect against cyber threats and unauthorized access. It has also greater spectral efficiency, which support the growing demand for high-speed internet and enable faster communication. 6G also improves error detection and correction. It ensures reliable communication even in challenging environments.
Okay, last but not least, let me talk about the misconceptions part. So the first part is health. Excessive exposure to high level of RF radiation may pose potential health risks such as cancer. So the truth is, RF energy is non-ionizing radiation, which is not strong enough to damage atoms or DNA. Studies have not shown it can cause radiogenic health effects such as cancer. And then second part is safety part. So the encryption makes the RF signal invincible and prevents it from being intercepted. The truth is, encryption protects the data, but the signal can still be intercepted. It just keeps the information safe even if someone picks it up. And the next part is legal part. RF signals can be freely transmitted without legal restrictions. But the truth is, in reality, RF transmission are heavily regulated by authorities such as FCC. While some bands like ISM bands are unlicensed, there are still limits on power levels and rules about avoiding interference with other services. Transmitting RF signals without adhering to these regulations can result in fines or criminal charges. So that's all from us. Thanks for watching this video. See you.